In this video, we're going to take a look at creating another script operator that's going to help us ingest a whole bunch of objects at once without having to sort them into particle groups. The way we're going to do this is use a user-defined property assigned on each object in the max scene. And of course, this is just one particular user-defined property. Right now it's called whoami, and it's an integer. It goes right now from 0, 1, 2, or 3. But of course, you can actually add as many of these user-defined properties as you'd like, say for things like mass, or joint type, or joint strength, or any conceivable property that you want to modify inside TP. You can define on the object level, and then when we bring it in with object to particle, we can create this script operator that's going to go ahead and read the born node output here, which corresponds to the born particle, and read that born node and say, give me that user-defined property that I'm looking for, and then go ahead and either assign it to memory for the particle, or in this case we're going to use that whoami to sort it into a particular group. So we'll go ahead and get started, and we will create a colors black box, which creates all those colors for us. But right now they're all set to use the global display type. We're going to go ahead and just select all the groups in here. And this TP group manager is just a little script that allows us now to select a whole bunch of groups and apply properties to them, and it'll automatically apply those to all groups. And say display mesh. Okay, so now as we select them, we see that. Okay, something that I want to take a quick look at. Right now, edit on the fly is turned on, which is good. If you try to ingest a whole bunch of objects at once with edit on the fly turned off, it can be a little bit slow and painful because TP is going to be building a material tree for the whole thing. So it's either a good idea to turn TP off when you bring objects into object to particle, and something else. It doesn't really matter in this particular case because this is just kind of a test scene. In a production scene, a lot of these objects would have their own unique materials or maybe instance materials. In our case, we want to make sure that they all have a material on them already, and in this case we're just going to use one material. And the reason we do that is to avoid having TP create a unique material for each object when it imports it into object to particle, which is something else that'll slow us down. So we've got all those now sharing the same material. Let's go ahead, select all those objects, pick them here, and we're still going to have to wait a second. I'll go ahead and put you on pause. Okay, well that took entirely too long. Let's hope we don't have to do that again. Anyway, the only thing that we're going to need to do with all these objects in the object particle list is say changes affect all and instance their shape. Don't have to touch their group at all. And I should mention now that this method that we're doing for automatically assigning groups does not work when you need tracking to be enabled. Because remember, if you use object particle and then you assign that particle into a group, it doesn't matter which group, this object particle tracking will be broken, or particle to object, etc. You just cannot use that. So you can only use this method for static objects, which is usually okay for things like structures or anything like that. Okay, so let's take a look at what we're going to do to, let's go ahead and hide our sources now. And let's go ahead and take a look at creating our script operator. We'll go ahead and use our template, drop it in here. We're going to go ahead and just rename this. We've got user-defined properties ready to go. Let's say find next, replace that name, register, and the top level name, and OK. And then of course we're going to also need a new class ID, so we'll generate one of those. And I'm sure you expert Mac scripters are thinking that you know a nice and easy way to automatically automate all this and even write out a new file. Please let me know how. That would be great. I'm not the world's best Mac scripter. I only learned a little while ago, but it's been incredibly fun and powerful. Learn as much Mac script as you can. It will definitely help on the job. Okay, we're actually going to assign the category of this operator into TP video 1, and let's go ahead and take a look here. We're going to go ahead and create a variable called myNode, and we're going to set it to be undefined in the beginning. We've got some parameters in our template for setting up description fields, and we're going to say it reads user-defined properties. And that second description field we'll go ahead and just leave blank, empty. Okay, our input now is actually, remember, we're going to be using the born node, and so this is a node type. And so our type, we're going to change the input to be a node, and we'll call it we'll call it born node. And right now, remember, with our objects we have that integer for who am I, and so that's actually going to be an int. Go ahead and put that here, and this name of this output is going to be who am I. Okay, so now we get into and we're not going to do any of the updating for version checking. That's kind of advanced stuff if you end up keeping the same script for a long time and want to be able to automatically detect for certain changes or inputs and outputs. You can add all kinds of code in here that will kind of keep your own script up to date. Really, it's pretty cool, but something I'm just not in the habit of doing yet. Okay, so what we're going to do is here in TP calculate, really what we want to do is, we'll throw out a little description here. We want to get the input node, read the user property, and then output that value. Okay, looking ahead, right now we only have one output and one user-defined property. Here in the future, we're probably going to want to add things like mass, joint type, joint parameters, rotation threshold, etc. So we're actually going to kind of build this around that future development. One of the things that we're going to do here is pretty extreme. We're going to go ahead and take out this if TP out ID equals. And the reason we're doing that is because we know already that there's a problem with that setup. And so in order to get around that, we've got to take that out. And what that does is it actually prevents the operator from checking for a specific ID. And what we're doing right now is we're just kind of plowing forward and saying, okay, well, I'm in the calculation function. If the input-output changed, then go ahead and proceed. And what we're going to do is we're going to say, if the input-output changed, not the input-output, but if the in-out input changed, number 0 has changed, meaning if the node coming into this operator has changed, which means is it evaluating a new object particle, input object, then do something. And actually what we're going to do is we're going to say if it's changed, then say myNode equals that. Get rid of this portion. And then what we're going to do is we're going to set up some logic that says if myNode is not equal undefined, then do something else there. That something else is going to be what is it? Case TP out ID of, which is where we control which output value is sent out. So in the event that the output ID, meaning our output ID here, is 0, then what we want to do is going to be enclosed in these brackets here. And what we're going to do is say get user, actually we're going to assign this to a variable. We'll call it my var equals get user prop from my node, and the name of this property is who am I, spelled like that. It's case sensitive, so be careful. Okay, then we're going to add a little check in here that says if my var is not equal undefined, meaning it has a property on it, then output my var. Else output, and this is where it gets a little tricky on deciding what to assign this value if it's not my variable. In our case, we know that we have whoami assigned from 0, 1, 2, and 3. So we're actually going to set this to be 4. So this will be kind of our catch-all. Okay, so that encompasses that. This encompasses this. And then we've got this final else already in here. This is part of the template. So if my node is undefined, then it's just going to output an undefined there, which is fine. Okay, let's go ahead and update this. Oh, I can't use it because we already tested this with this name. So what we're going to do then is we'll replace all instances of that with UserDefinedProps2. So let's find the next, replace there, and there, and there. Okay, but not that one because that'll just muck up the name. Okay, let's try it again. Hey, it worked, great. So let's actually go ahead and save this as TP script operators, video examples. What's this going to be called? Well, let's call it UserDefinedProps2 MS. Okay, so we'll go ahead then, and it's under our helpers, under the TP Video 1 subcategory, and there it is, UserDefinedProps2. We've got our new helper. It's got that input we defined, our input handily shown here called born node, and the output called whoami. So we're going to take that born node, pipe it in there, and then this whoami is going to be an integer coming out. And what we're going to do is we're going to use a 1 to x, since 1 to x uses an integer to control which output gets activated. And then based on that number, we're going to assign that particle into a certain group. So let's get the 1 to x out here. We're going to be dealing not with booleans, but with actual particles, because we want to assign those particles to a specific group. And let's see, I know we're going to need at least, we've got 0, 1, 2, 3, and 4. And so we'll get that there. And what we're connecting now is connecting the particles. These outputs are actual particle types. They're of type particle, that is. And what's going to happen is when object particle starts processing all these objects, and actually we kind of went overkill. I usually prefer to just test it on a few to begin with, so sorry. Hopefully this doesn't blow up, but we'll find out. So object particle, as it starts importing all these objects and processing them in TP, it's going to do, we're going to have it do a couple things. We're going to take the born particle that's created, and we've got this x input, which is the integer. That's going to be this integer here. And then the in, the actual in value that we're going to be using in sorting, comes in here. Connect that to the born particle. Now what we have is these particles being born. They output both the particle and the born node. Okay, so the particle comes in, gets sent into this 1 to x input. That 1 to x is also looking for an integer. The object particle takes this max node, sends that max node into this born node input. We do our logic processing on it here. We check and see if that value is changed, meaning, hey, am I getting a new node coming in? Okay, I'm getting a new node. That's good. So I'll go ahead and assign it this variable to that input, whatever it is, that node. And then if this variable is not undefined for some strange reason, then take a look at my output IDs. And if my output ID in this case is 0, then we're going to go ahead and create a local variable inside here that says, hey, my variable equals userProp, get userProp, my node, who am I? And that calls the MaxScript function that looks at the user-defined property on that node, looks for that text there, and if it finds it, and if it's not undefined, then it's going to output that number. And remember, that number actually equals the value, whatever who am I equals. Okay, but if the object does not have this this variable here, this user-defined property, then it is going to be undefined, and so we're going to output 4 in that case. Okay, well, enough talk. Let's get into some action. Let's see what happens. Let's clear that, make sure we're not hitting any problems. That looks good. Is TP turned on? No, it's not, so that helps. Okay, so we've got our instance shape, our user-defined properties. This here, oh, well, it would help if we actually assign the groups, wouldn't it? It's always something little. It's either you forgot to pick the node in the node helper, or you didn't assign the groups. Orange, yellow, green, and blue. Okay, so blue's undefined, and we've got 0, 1, 2, and 3 corresponding nicely to these outputs here. Okay, so look at that. So our objects come in, get turned into particles. The actual node that's listed here gets processed, and we look at that user-defined property, sends out that integer for us, and that integer actually determines which output gets activated here and sends that particle to a specific group to be assigned. Let's actually stir this up a little bit and get some, let's make some of these not defined would be good. You and you. Okay, so look at that. Those two, and our blue's not very blue. Let's go ahead and tell all blue particles to be a little bit brighter. And this group manager again is included on the DVD under assets. Okay, so there's our two guys who were not defined. Their nodes did not have a user-defined property, and so they came out as 4. And that 4 then sent them into the blue group. Okay, so this is user-defined properties, accessing them with the TP ScriptOp, and then as you go ahead and you start adding more, actually first let's save this. Oh, it's already saved. As you start adding more inputs for different properties, whether they are things like float, and maybe we could set one up for joint rotation threshold. So how much rotation threshold does it take to break a joint on a per object basis? We could import that, and then what we would do is just add another value here, another output, where it would look for whatever that user property was that we named for this. So it would probably match exactly, just to make it simple and clear. Hey, get the user property from that node called joint rotation threshold and output it there. And then what you could actually do is you can actually have multiple outputs coming out of this user-defined properties, one for pretty much any kind of property that you want to bring into TP. So it's a really good way to ingest a lot of objects all at once, as long as they do not need the object particle or particle object tracking. Initial velocity probably does not work either. So just make sure they're static objects, so usually structures or inanimate objects. And then from there you can use your user-defined properties, modify it with as many inputs as you need, and then just control the output ID checking here. Check your property, and then output based on whatever. And this is where you're going to have to decide, hey, if my joint rotation threshold for this object is not defined, well then what's a good joint rotation threshold value? And actually in TP we find that in some scenes, I don't know if it's scene scale specific, but, and this is totally off topic, but values of like 200 are about as high as we wanted to go. Otherwise we'd start to see some exploding behavior. So just watch out for stuff like that. Okay, we're not going to save it at this point because we don't want to include this joint rotation threshold. We'll go ahead and just leave it at the pristine Who Am I version. And I do just want to add one other little comment about the in outputs here. You can actually build an interface inside here, and you expert Mac scripters will know how, where you can actually kind of mimic some of the behavior of like 1 to x and x to 1, where you add more inputs, and it could actually dynamically maybe extend this and add text fields that you could, or edit text fields that you could actually type in the name of that user-defined property yourself. So that's just kind of something looking forward to the future. Okay, well, user-defined properties, there you go. Let's go ahead and move on.